lesson is on 12.3 and 12.4, and we're going to begin talking about surface area. Now, chapter 11, we talked about just area. All of those formulas that we learned in chapter 11 are going to be very important to us for chapter 12 because surface area has something to do with area, and we're going to use these formulas that you learned over and over and over. Okay. There's one thing that I need to make sure we understand before we get started with surface area. We need to talk about this word oblique prism. You're not going to see this a whole lot, but take a look at this prism here. This is an oblique prism because it's leaning over. Anytime you get a figure that is leaning, that's going to be an oblique prism. Okay. When we see this, we are going to use the same formula as a regular prism. Nothing's going to change. The only thing we need to think about here is where is the height going to be still? We always go straight down to get height. So when we get into volume section, that's going to be important for us to think about the straight down. You're not going to work with oblique prisms any differently, but there they are. We can use them if we need to. Let's talk about this part. One part of surface area is talking about the lateral surface area. Okay. So I want you to pause the video for a second. You do need to make sure you have down all of these notes that are on this slide here. Okay, so go ahead and take a second to do that. All right, now that you've got down these notes, we have this new word that we've thrown in there talking about lateral area, lateral faces. Okay? So when we talk about surface area, let me just kind of talk 1 minute about the concept of surface area. When you talk about area, you're talking about covering an area, literally covering an area of grounds or an area on a shape. Okay, so if you look at this cylinder I have, I'm going to come back to the cylinder later, but just to get the idea of area, this circle is a two-dimensional covering that we can put on the top of this cylinder. And when we get the area to that circle, that's part of our total surface area for this whole figure. Okay? So when you're thinking about surface area in general, just your usual, I'm just going to write it right here. Basic surface area is talking about covering a figure completely, all the way around. Kind of like wrapping a wrapping paper at Christmas, only we're going to have no overlaps when we talk about surface area and the covering. Okay? How much area does it take up to cover a certain three-dimensional shape? That's surface area. Okay? Surface area is like the total, all the way around, every side's taken into account. It's a little bit different when they throw this thing lateral area in there. Lateral area is taking the area of all the faces that are not bases. Okay? So look at this prism. And now what can we call this prism? Remember that prisms are named by their bases. Okay, so take a look. What is the shape of this base right here? It is six-sided. So this thing right here is a hexagonal prism. Okay? So in a hexagonal prism, if they ask you to take the lateral area of a hexagonal prism, they want the area of all of the faces that are not the bases. Okay, take a look at the picture you've drawn in your notes. The base is on the top and the bottom. These other faces are the ones that are going to be attached to those bases. Okay? A lateral face, can you see what that was pointing to? That's talking about these things that I colored in black. They're all around the shape. We could go all the way around. Okay? Now, this is not a prism, this is a cylinder, but this pink part represents all the way around the cylinder. I want you to think about this prism here. If this is a hexagonal prism, how many lateral faces are there going to be on this hexagonal prism? The answer to that is 6. Because take a look. How many sides are there? On a hexagon, there are 6 sides. So each one of these lateral faces are going to be attached to one of the sides of that hexagon. Okay? So if it's a hexagonal prism, it's going to have 6 lateral faces. Okay? So if a question asks you to find the lateral area of this prism, then we're just going to think about what shapes are those faces that we need to work with, what are dimensions, what's the area for that shape, and let's see if we can find it. One thing I want you to add to your picture of this hexagonal prism. I'm going to tell you that the altitude or the height of this prism from top to bottom is 8 centimeters. I'm going to tell you that one of the sides of your bases, one of the sides of that hexagon is 2 centimeters. Okay. Can we find the lateral area of this right prism? We're going to find the area of all the faces that are not the bases. What is the shape of each face in a prism, excluding the bases? We're not talking about the bases, we're talking about the lateral faces. Can you see rectangles all the way around there? And how many of them are there? There are 6, and they are all equal to each other. If I just kind of took some wrapping paper and wrapped it just right around this hexagonal prism, and then I kind of laid it out flat, and you can see the creases there. Look at this. Isn't this what it's going to look like? There are 6 of those. We do not include the bases on this. And what is the dimension of every one of these little faces? It's at 2 centimeters by 8 centimeters. Is that not correct from the information I gave you? If this is a right hexagonal prism and this is a regular base here, all of these are going to be the same size. 8 times 2, let's get the area of each one of these little ones, and then that's going to give us that lateral area that wraps all the way around this prism. 2 times 8, 16 centimeters, that is the area for one of your faces that is not the base. Okay, so what's the area for all these lateral faces? 16 centimeters. Okay, so if you wanted to find what is the lateral area, what could you do now with 16, 16, 16, 16, 16? Add them all together, then we have the lateral area. You should have a calculator nearby. So take your calculator and add up 16, 16, 16. Or can we just do 16 times 6? The lateral area is going to be 96 centimeters squared. We are still going to do the squared because we are still talking about some type of area. So finish it out with units squared. Let's try a couple different shapes here. These are still prisms. We're wanting to find the lateral area of these prisms. You do not have to draw these. Take a second and go get your study guide intervention book. This is on the front side of 12-3. Okay? So after you get that book in front of you, we are going to draw something with these pictures, but we're not going to draw you don't have to redraw the whole thing here. We're going to draw the lateral area. We're going to lay it out flat. So take a look at this triangular prism. If we just kind of had, if we could kind of cut this three-dimensional figure and just lay it out flat, let's draw the net of this figure. I'm going to start with the thing that it's sitting on. So take a look at this bottom piece it's sitting on. This is a 4 by 10. Okay, can you make sense of what I'm drawing here? Now, let's take and let's just flip down. I'm going to erase this. Let's take this side that's standing up and let's just kind of flip it down. If we could unfold this thing, isn't it going to unfold to be a rectangle just on this side? And what are the dimensions of this rectangle? You still got 10 right there in the middle. This flips down. And do you see that this is 3 meters right here when you lay it down beside? Now take a look at this piece that's kind of slanted and on top and on the left side here. Can we think about just opening that up and laying it back? Okay, it's still 10 down the side here. I could put 10 there if I wanted to. What is this dimension right here gonna be? And take a look. It comes from this part of your picture. Do they tell you what that number is? No. Is it going to be the same thing as 4? No. Is it going to be the same thing as 3? No. Hopefully you're seeing some kind of connections here. Look for right triangles. They're all over the place. Here's a right triangle. I've got one leg is 3, one leg is 4. How can I find the third leg? This looks like a good problem for Pythagorean theorem. If you've noticed among the semester as we've gone along the semester, 3, 4, and some other magic number make a very simple Pythagorean triple. If you know the pattern here, 3, 4, 5 is always going to make a right triangle. Okay, so you can solve this and it's going to give you 5. I'm going to save a little time here and I'm going to just go ahead and say, oh boom, we know it's 5. Okay. Alright, so take a look here. Did we open up and we get all the little rectangles that are wrapped around this triangular prism? Now, I will ask you, what about these little triangles here? Those are your bases. Could we draw them in here if we wanted to? Sure, we could draw them in here. We could put them here and here. But for lateral area, do we need the bases for lateral area? No, we do not. Now I covered up my 4 there. We don't actually need the bases. Okay, so here we are. I want you to take a look. Let's get the area, and let's just find the lateral area of this problem number 1 here. 10 times 5, that gives you 50 meters squared for this piece. 4 times 10 is going to give you 40 for this piece. Okay. 3 times 10, this gives you 30 for this piece. Lateral area, let's add them all together. 50 plus 40 is 90. And then add that third one, 30. 120. Your answer for number 1 is 120 meters squared for the lateral area of this prism. Okay. All right, number 3, I want you to try this one, thinking about what we talked about here, thinking about what shape this is, thinking about the dimensions of all of your lateral faces. Try number 3 on your own.